Hello, good afternoon and welcome to today's webinar on teaching Group Python programming using VoIP and Trinkets, with me, Beverly Clark, as your host and Holly Billinghurst as your presenter. I am the CAS National Community Manager responsible for the management and delivery of the Computing of School Community of Practice Programme as a part of the National Centre for Computing Education, the NCCE. This webinar is part of a series of webinars under the CAS Inspire programme. We're looking at remote teaching and remote learning. During the session, please use the question window on the right-hand side of your screen to ask questions. The top of the window has an orange rectangle, which can be expanded or collapsed. There's also a copy of all the notes used in today's webinar available to download during the session, and Holly will direct you to those later on. There are actually 3 documents uploaded today. If using social media, please use the hashtag CAS Inspire 20, please. I will now hand you over to Holly to go through the objectives and start the main part of the webinar, and I will join you again at the end of the webinar. Thank you very much. I'm handing over to Holly. Let's just swap across.
Fabulous. Okay, right, so let's double check that you can see our presentation. Fabulous stuff. Okay, so I'm going to make sure we have our questions open on the side so that you can ask your questions as we go. There is a chat facility, but when we chat, we wouldn't be able to see those when we know that it's not working beautifully at the moment. So please do add your questions, add your comments into the questions section, and I will respond to them as we go. So please don't wait for the pauses, add them in, and we will adapt the webinar so that it matches your needs. Okay, so let's just make sure I can see everybody. Lovely, lovely. Okay. So this is our 4th webinar on teaching, so this time it's for teaching Group Python using online tools. In today's webinar, what I'd like to be looking for is looking at the different ways that we can teach collaboratively with our students, either using an online individual IDE or using ones that we can actually work alongside, testing out what works best for you, specifically for your students, rather than you as a whole group of computer science teachers. And also looking at the benefits and drawbacks of online collaborative coding. We're going to be looking at debugging our student code from afar, because that was the first thing that absolutely terrified me when I went from looking at a classroom where I could actually go physically up to my students and assist them, to an online environment where I knew that they were potentially struggling with bugs and issues with their code, and I needed to find ways where we could actually assist them. We are going to introduce the topic of SNOT, which is one of my favorites that I have been using for years and years in my classroom, and how we've created a digital version. And then also trying to look at how you can adapt your resources without reinventing the wheel. Okay, so let's get cracking. There are absolutely tons of things out there that you could potentially use as collaborative coding environments. So what I've tried to do is I've just brought in a few examples so that I can show you how I've used a variety of resources for my students, whether they are large groups, small groups, and also one-to-one. And I know that some of you are teaching multiple classes at the same time, so I wanted to sort of bring in a huge range of resources, but it is important to be aware that no one resource is perfect for absolutely everybody. So this isn't, the purpose of this is not for CAS to say you should use this particular resource. It's these are the things that people have come back to us or we've used personally, and we're able to say, yeah, these are great. So we're going to look at a variety of different resources which will cover Key Stage 3 and primary to a certain degree, all the way up to 6th form as well. So you can see here I've got 4 main resources that I'm going to be focusing on. We're going to have a look at Repl, we're going to have a look at Make Code, Trinkets, and also Code Collab, which is another version. And again, this is going to be very specific to your school in terms of the way that you implement it. So look at the way that your remote teaching has already worked in terms of things like theory. The idea is to take the lessons that you would have already planned for this term and to be able to turn them into a digital version. Okay, so the first thing I'm going to look at is how I would be considering my class dynamic, looking at actually what I am trying to achieve, and then also what worked in my physical classroom. Beverly, we have an issue from Bart who can't hear. Would you be able to pop on?
I'll pick it up. Yeah.
Thank you very much. Okay, so I'm going to start off by getting you to pop in some questions for me. If you can give me an idea of which levels that you are looking to code for. So whether you are primary, whether you are Key Stage 3, Key Stage 4, or whether you are sixth form. That way, what I can do is, as I'm explaining these, I can adapt what we're presenting to work for you. So again, if you pop that into the questions, that works really well. Fabulous stuff. Oh, look, we've got a huge range. I'm just going to bring that out. Okay, so we've got some Key Stage 3, we've got some secondary, Key Stage 5 in there, Key Stage 3, Key Stage 4, Year 7 to 9. Lovely, and GCSE. Okay, so we'll make sure that obviously we are very much sort of focused on those areas. Okay, so the next thing I'm going to show you is make code. So I've done a little bit of a video in terms of me actually setting these up. Make code is specifically for microbits. So this one is a collaboration between you as the teacher and the student, because you actually get to see them coding live. So the collaboration is not between the actual students, it's not paired programming. It is restricted to microbit programming, but it does include the micro Python. So when we're talking about Python programming and we want our students to be really, really engaged, if you already have distributed your microbits to students for them to use at home, then make code is really, really powerful as an online tool. So one of the things that I've been doing over the last few weeks has been to do for Key Stage 3 and also a little bit of Key Stage 2 as well, is actually rather than using the Python version of Make Code, I've been using the JavaScript and the block code. And we've been doing that online. So my students that actually have the microbits with them, they can connect, and those that don't can use the emulator. And that's been absolutely amazing for us. The difference on here is that for the Python version, they do need to have the physical device. So that is a little bit of a constraint for us. So certainly for me, particularly using the Python version, I run my little courses where we send out a little box of tech to each student that wants to join in. So we make those into smaller groups. But if you wanted to do this for students where you have lots of students, then potentially you might want to take this version and then move it back into the JavaScript area. It's quite powerful for students actually to test out their Python skills and then to translate it into one other language. So this particular one, what I've done is I have created a little bit of skeleton code, and we're going to talk about the idea of prim later. Specifically when you've used your skeleton code. I've then created it in my Microsoft Classroom. Remember that this is still in beta, so there are a few little intricacies, so things like not having an emulator for Python, not quite working yet. But I really love this concept of being able to go in, give them a class code as we run a live class, and instead of having to type in lots of different letters and whatnot, they actually select from 4 drop-downs. So it makes it a little bit more accessible. And at the end of your class, what you can do is you can actually download a classroom file. You can export all of the code that your students have created as Word documents. So it actually takes the code, it takes your original code and shows what they've done and puts it into a Word document that you can then add your feedback to and send it back to the students. So having used now this particular classroom for a number of months, it is something that I would personally recommend for large groups, because I'm able to give my initial code to my students. You can then, so you go up to the dashboard at the top there, and from that dashboard you can then send that code out, and you can actually edit as you go. So if you wanted to create your skeleton code as you go along, it will right, okay, but we will come back to that question, Beverly. We've got some more questions from Bart on there in terms of the audio.
Okay, thanks.
Okay, so in terms of being able to use this, what we do is you go up to your editor, you can create your skeleton code as an introduction, then send it to your students. The students then get a copy of that code, and you can actually see them then developing their own versions. So this is really, really good, specifically for Key Stage 3 and 4. The reason I don't include Key Stage 5 in MakeCode as much is because although it has the potential to add in areas for things like object-oriented, certainly for the JavaScript, there's no reason why you couldn't use it. It's just not really the interface that we would be instantly giving to our Key Stage 5 students, but it is still incredibly powerful for Key Stage 4 if you want them to have something physical in front of them where they can see their code running, and it's not just a command line. Which of course, you know, that is what they're going to have to do. But with the newer Key Stage 4, with the newer GCSE qualifications, that's going to allow our students a little bit more free range, if you like, in terms of being able to learn something that they can physically get their hands into. So in terms of MakeCode Online, consider your instructions. One thing to be aware of is that you need to have built these prior to setting up your classroom. It is in beta, so what you would need to do is you need to create it, you need to download your classroom file, and then at the start of the class you then need to upload it. So it does require a little bit more practice, and the classrooms themselves are not persistent, so they are only whilst you are personally live. Okay, let's have a little look at trinkets. So I promised you trinkets, and here they are. At the top of this particular slide, you will see a little bit.ly link. And that bit.ly link will allow you to go direct to the page that I am showing you on the screen and have a play as well. So it's definitely worth having a play as you go through this. So I'm going to show you what this actually looks like while I was playing with it. But the nice thing about trinkets is that you can create your skeleton code in advance, have them all saved in your Trinket account, and then you can embed them into either web pages or your VLE. So if you are using something like Moodle, or you are using Google Classroom, where you can have your little HTML pages, you can actually embed these directly. So again, students aren't collaborating directly with these particular trinkets, but you are giving them the ability to access an IDE without them having to install anything on their computers. So lots of us have been having these conversations about our students who may not potentially be able to access a laptop or a desktop during our lessons, because maybe there is only one laptop throughout the whole of their household, but they maybe do have a tablet, or they have a phone. This one's a little bit more difficult on a phone, but it is achievable. On a tablet, you would definitely be able to run your trinkets, and so you don't have to have an installed IDE. And this allows them to adapt your code. And the nice thing about this is you can create your skeleton code, you pop it onto your web page, and then as they adapt it, the original doesn't change. So you can then add in instructions, you can add comments. There are ways in Trinket where you can actually have some interesting sort of like little debugging things. So you can see there, you still have your debug, you get your error messages. So this allows our students to actually run our Python code as we would expect them to see, even if they were in the classroom. So if you're using something like IDLE to run inside your classrooms, trinkets are really powerful in terms of being able to run something which looks really, really familiar to them. And you can add as much instruction or as little as you like. And of course, once you have created one of these, then you can create any number of them, and then you can just embed them. So you can start building up a toolkit of your resources. And of course, if you already have a toolkit of resources where you have your Python files, you can copy and paste them into these trinkets, and instantly you have an online, I want to say a digital version, but of course your Python files are already digital. You have an online version of them. And this allows us to test things out. And trinkets are actually probably quite recognizable to a lot of our students who are using a number of different computer science websites. So there's a few which are quite famous now, and a number of them are now embedding their challenges as trinkets. So our students are reasonably familiar with them. And if not, it doesn't take huge leap from IDLE into Trinket. The other thing to be aware of with trinkets is that they can share them with you. So using the share button, they can share it and email it directly to you. They can also download them to their personal computer as a .py file once they have changed the code. So their changed version can then be downloaded and either uploaded to their assignment or saved directly on their own excuse me, on their own machine. Okay, so this one, I put in here Key Stage 3 to Key Stage 5. Ultimately, anything you can do in IDLE, you can do in a trinket. That includes running things like Python Turtle for our Key Stage 3 students. The turtle in Trinket is lovely. You can actually change into a proper turtle. So you can change all the little bits and pieces. So we had a lovely spring lesson a while ago where students were given a piece of skeleton code, and then we designed random petals around a flower, and we had little bugs that were moving around the screen. And that was purely from a piece of skeleton code we created in Trinkets, and then each student was developing their own. So for this one is probably the easiest version of taking your standard lessons that you would have inside a physical classroom, especially if you're using IDLE. This is the easiest step into creating that digital classroom. The only difference in terms of this is that you don't get to see the students' code as they are creating it. So there is no live link there. So if you did want a live link, one of the ways that you can do that is to have a classroom where students can share their screen. Now, obviously, and we've talked about this in previous webinars, that sharing screens for students does produce that risk there there is a safeguarding risk. So definitely, if you are considering sharing student screens where it is not an application specific, do consider the safeguarding implications of that. Okay, so there is the introduction. So the introduction is basically us saying, right, how do we take our physical classrooms and turn them into a digital environment? But we want to go one step further, and we want to look at collaborative coding. So please do add in your questions as we go. I am going to stop in just a second and answer some of those. So in terms of collaborative coding, I cannot take any form of credit for the idea of pair programming. I learnt this from the fabulous Alan O'Donoghue, who came into a school where I was teaching many, many years ago and introduced this concept of having a driver and a passenger. I was always a little bit concerned about group work for coding because I worried that one student would take over, and it utterly changed the way that I taught. In terms of a digital classroom, in terms of producing our live lessons, this really does change it from a lecture like we're having here into this interactive classroom and the students really, really engage. And we have lots of ways that we can have this collaborative classroom environment. So in terms of the fact that we have got some significant distance between some of our students, and even if they're not particularly physically distant from each other, they haven't seen each other now for a good few months. This allows them to create that group work environment in a nice protected bubble. So, and the other thing is obviously with us not being able to physically walk around our classrooms and help them, this ability to work in pairs reduces how often they get stuck. And it also allows you to add an element of peer feedback into your lesson, but giving it a clear focus. So it's not a chat area. You are giving them, this is your code. If you need to ask each other questions, you have to put comments in the code. And of course, you can see everything they write. I have put a link up there using a tiny CC link. That is to the video that you can actually see embedded onto this page. That particular link will take you to an example of me using a paired programming environment where I have assigned, I was actually using Repl in this particular one. I had a number of students with me. It was actually quite a small group for this one, but this is purely because this particular group is a group where we have agreed with parents to stream the lessons as well. With my larger groups, obviously it's not recorded and streamed. For this one, what we did is we took my skeleton code, I explained it as we were going, and each group was given a copy of the skeleton code, and we used the Repl multiplayer mode. So I assigned the groups, I gave them their share link at the start of the class, and throughout that class, we were working together to allow them to produce more code in terms of fixing the skeleton code. That's why I left some errors in there. I was showing them how to then develop it further, and then giving them little challenges as we went through that particular class. Now, of course, I'm talking about the benefits of online pairs, but of course we do want to be aware of some of the drawbacks. You do need to have a little bit more classroom management. When you have larger groups, obviously working in 2s and 3s means that you are quite likely going to have maybe 10, 20 browser tabs open. So you do need to make sure that your internet can handle having that many open. It does obviously reduce the one-to-one time, but it does produce one-to-one time with students where you can pop in and you can give them feedback that everybody can hear, but you are actually seeing them code live, and that's absolutely amazing. So you can see there, there's like a little a blue area and an orange section, and that was actually, I could see where the cursors of my students were, and I can see that they are actually having a conversation, so I can see their thought process, and it worked so well. And in fact, it worked so well that we were taking this particular group and streaming it. One thing obviously to be aware of is if you're not physically seeing every student's code at the same time, are they actually completing the work that you set? My experience of this is actually, yes, they do. Especially if you are talking like this and you are swapping between the screens and you're giving feedback, they never know which one you're going to jump into. So actually they are starting to work together in a much more effective way. And it changes it from being that student just being passive and watching you present into them actually needing to complete some of this, because you might then go into their code next and start giving feedback, even if it's really, really positive feedback, and go, oh, have you considered doing this? They want to show that they have actually moved forward a little bit. And because they're working with someone else, again, that pushes them forwards. It does open, though, the potential for unsafe use. So obviously this is something to put into your risk assessment. You can see there that my students are actually typing to each other and they're actually having a conversation, but there is very little in there to stop them from putting in things that you wouldn't want them to be talking about. They can't share their screen. They can't talk to each other from an audio perspective, but there's always that minor risk there of them putting something in there that you wouldn't want them to be talking about. However, they also are aware that you can see everything that they do. And there is also a time hop, so you can roll back and roll forward to see what they have put and what they've deleted. In terms of doing things like this, our collaborative coding works best in 2s and 3s, just like a real classroom. If you have 4 or more in a group, it does get a little bit unwieldy. However, 3s worked absolutely brilliantly for a lot of the larger classes that I was working with. The other thing is you do have to obviously have set up the resources in advance. You only need to have created your original skeleton code though. You don't have to recode every single group. And I'm going to show you how to do that in just a second. And the last thing to consider is make sure that you have a backup in case the software goes wrong. With the best will in the world, we are using these internet-based resources, which are not infallible. And although they haven't gone wrong very often, I have had a couple of classes where everything has been down and we've had to revert to plan B, which then didn't work, and then plan C, and we ended up with sort of plan F, and that was Notepad. So don't panic if things do go wrong. Even if you've planned this amazing pair program lesson, you can always come back to it next time. Okay, so I'm just going to have a quick look to see if anybody has any questions. Okay, not yet. So Repl. This is the one that I've been using quite a lot over the last few months. I've actually been using Repl for a number of years, but I've only recently found the multiplayer mode, which allowed me to create this idea of either collaboratively working with all of my students, so everybody could bundle into the same piece of code, which has been interesting, or changing it so that we could have this paired programming environment. So the idea here, and I'm going to show you the video that we have for this running, is I have actually created a piece of code and then set it up as a skeleton code within my own folders. And you can see here, I've decided to add in some questions. I might decide to break things, so you can add your own questions and potentially errors. So as long as you know what that error is meant to be, then obviously that skeleton code suddenly becomes a lot more the middle part of our prim. And of course, we are going to look at the prim area as well. So in terms of this, you can see there that I've just changed solved from false over to true. And I knew that that would break my code, at which point I could then add in some questions at the top to say, how can you make this work functionally? Can you find the error? So specifically in this case, find the logic error in the code. Now, of course, I'm not going to let my students see my original code. And the nice thing about this is that as you change this, your students won't actually impact on the original. So we talk about this using a fork. So essentially a fork is to take the original and then create duplicates of that particular iteration of your code. So up here, you can see what I was originally doing was to add in each one as a comment. And then I realized actually that might be a little bit too easy for my students who are maybe that little bit more advanced. So what I did is I created a multi-line comment and I actually created my lesson objectives, or rather my lesson questions and tasks at the top of the code. So when I shared it, everybody had their objectives really, really clearly in front of them. Now, if you'd like to have a look and have a play with this particular piece of code, and I thought this particular piece of code might be quite useful for you as you are developing, because we have a digital debugging duck. I love my rubber ducks. I know loads of you have actually already have talked about rubber ducks with me before. Rubber duck debugging is something that came out of of industry, where junior developers would get they would get stuck. They wouldn't be able to solve their own errors because they created this brick wall mentally in front of them. So instead, what they did is they were given a rubber duck, and you have to talk to the duck in words that a rubber duck would understand about the errors that you have encountered. And essentially what this particular piece of code does is it's going to ask questions and give you a response. So you can see there, have you compared your code to a similar problem? Nope. What happens when you run your code and I'm able to type things in? It actually doesn't matter what I'm typing in terms of the program. What it's doing is it's asking me to explain myself, and it will keep asking me these very open questions until actually I've solved my own problem. Excellent. Okay, so whilst this finishes off, Ruth has said, I tried group coding last week, but the students couldn't edit the code. So you've used multiplayer link. Ah, right. So yes, the students will need to sign in. Usually I suggest to them to sign in using a Google account. They can create a free Repl account. They don't need a paid one. When you share your code, it's important to click on the share link rather than the URL at the top. So you can see there, you've got version control down the side. That will allow you to adjust your own code. The bit that you actually want to be clicking, and I know this is actually in the video as well, is when you share your code, you want to be clicking on the share link, which is at the top right, and click on the copy link code. So you can see there, I've got my CAS Inspire. Then on the right-hand side, I'm going to fork that code to create each of the groups code. So you can see there, it now says CAS Inspire -1. It'll put a -1 or -2 at the end. I like to change mine to group 1 so that they're really clear. 1, 2, 3 is absolutely fine. Okay, and at that point, we're going to click share. And rather than copy the Repl link at the bottom, we need to copy the link that is the invitation link. So the Repl link will allow them to get to your original code and fork it. The copy the link, which is slightly up, that will allow them to get to the multiplayer link. It is maybe not the best or most intuitive user interface in terms of the copying of the link. So yes, you do need to make sure you copy the share link, and they do also need to sign into Repl, but they don't need to have a paid account. Ruth, I hope that answered your question okay there. So for those of you who are struggling a little bit with using Repl, or our students wanted something a little bit which is more simple, or you want something where they just want to access the code, but you don't want to have lots of paired programming. This one is an alternative. So Code Collab is an alternative, but again, unlike a bit like with our Microsoft code, it is not persistent. This one persists for 2 weeks. After that, it's all gone and they can't access it again. Claire, that's an interesting one. I have lots of students who use mobile devices. Are any of these available on a mobile device, or do they need tablet or PC? In terms of coding like this, Code Collab definitely works on tablets. In terms of phones, it's a little bit more difficult. Make Code definitely works on mobile phones. Code Collab works okay on a mobile phone, definitely works on tablets. Repl, I believe there is actually an app that you can use, but again, it's not as easy, because if you are looking at lines and lines and lines of code on a small mobile phone, it can make it more difficult. It's not impossible. So if you are talking about using code specifically with students who are working on smartphones, my suggestion would probably to go back a level and use trinkets with them. It does stop them from being able to work and do the pair programming, but they will be able to program directly on their mobile phone, so they'll be able to access the trinket in a mobile environment. So in terms of this one, it looks very, very similar to Repl. But you do have to set up each one individually, and you can have a look at this one again using the bit.ly link at the top. If you want to open that up in a browser, you can have play. Again, it will only persist for the next 2 weeks. So this was set up for you yesterday, so we have a little bit of time if you do want to play with this afterwards. So for this one, again, you can add in your questions, you can add in your errors, you can create a share link, but that share link is direct with everybody. They don't need to have an account for this particular one. So if you want students that don't feel comfortable using an account online or using a Google account, then this one's quite useful because they just use that link and they can get straight in. You do have to download the code though. Because as I say, this particular one doesn't persist. So if you put your code up there, you come back 3 weeks later, it will be gone. So if you want to have something like this, you would need to create multiple versions. They have made this free for the foreseeable future. They are essentially at this point, they are trying to assist schools. A lot of the other collaboration tools that I found were very much to do with having one-to-one code. So they're more to do with interview technique for not so much for our students, but for adults who are actually applying for jobs. So rather than going into an interview before you actually even get to interview, quite often you'll have that code test, and they'll do that online. These things are absolutely super. So if you are supporting your students and they are actually looking, and this is more for Key Stage 5, if they are looking to either go out into industry and you are supporting them with their interview technique, these are really, really supportive. Use something like Repl, use something like Code Collab, because you can actually see them creating their code as they go. So it is a real-time coding environment. The other thing is obviously if they're looking to do computer science and then potentially in something like the Oxbridge program, again, using something like Repl is again going to be really, really powerful, because it's likely that that is going to be something that will be part of their interview for university. So if you are teaching Key Stage 5, just be aware that they are quite likely to come across something like this, either when they have an interview for a job or for university. So it's quite useful for them, even once we're actually back in our physical classrooms, for us to use these with our students so that they understand that this is what they look like. Okay, so I know we've had a couple of questions, but I'm going to pause for just a second in case we have any more questions specifically about our collaborative environments. Okay. Super stuff. So in that case, I'm going to move on in terms of some of the benefits of everything as a whole. So using a digital environment. This is based upon a lot of the feedback that I've had from teachers who are trying to create their digital programming lessons. One of the things that we have been using in many CAS conferences for years and years and years, and I remember this in one of the very first CAS conferences, was the benefits of hands-off. And I know that there are certain people who have these great big posters in their classrooms, which is "Don't touch my keyboard." It's so natural for us to want to show the students how to solve their code, and one of the really big worries that a lot of teachers, new teachers to computer science come in with is that potentially their coding isn't high enough to keep up with the students, especially the students who are already sort of quite high level. Using hands-off works for a number of purposes. Firstly, if you are not hugely confident in your particular coding ability, the benefit of hands-off is that actually by saying to a student, I don't know, we're going to have to look up how to solve this, that actually helps that student to move themselves forward. It makes our students more independent. So actually having this physical separation, I do apologise, my neighbours decided to mow their lawn. Having this physical separation allows us to force students to unstick themselves, and by saying to our students, actually, I can see your code, but I can't fix it for you. It's pushing them that little bit further, and it's actually doing something that is good practice and has been held as good practice for years and years and years. By having this collaborative environment, students can actually see you helping others. So where we were talking about having our paired programming and you going between each of the tabs where you have set up your groups, because you're not giving your feedback specifically to that group, you're giving it to everybody. Another pair may actually be stuck on the same thing, so you're actually providing your verbal feedback to everybody and they can hear you. It's not just that they're actually overhearing a conversation. You are presenting that issue to the whole class and you are identifying ways that a number of students, so these common misconceptions are being really, really clearly shown to absolutely everybody. Ah, brilliant. So we've got here, one student modified the line of code that I gave them so it stopped working and then put lol at the end of the line. Was he doing this on purpose? Possibly, yeah. And I'd almost use that as a teaching experience and actually say, oh no, look at what this student has done. Let's put this up on my version. I'm going to change my teacher version and change the line of code. So I might comment out my one that definitely worked, put their line underneath with the lol. And I'd want the whole class to then look at that and explain to me, why is this funny? Why is this? Why doesn't it work anymore? What has this student done to prevent the code from working? So take the fact that they are potentially trying to kind of maybe undermine a little bit of what you're doing, turn it round on them and say, actually, that's really good. So you've created an error. Let's work out if we found this, maybe if somebody was to crack our system, they changed a particular line of code, what impact would it have on our system? And then you could use that to then go off on a little bit of a tangent in terms of looking at, well, how would you prevent somebody from being able to change your code in your system? Excellent. So I've got, they love changing student code. Yes. So then put achievement points or rewards for you to fix it. Absolutely. Yeah. So if you have the ability to give out achievement points or to, and if you don't have achievement points, then potentially have like an end of class certificate, have that popped on the side of a PowerPoint, save it as a PDF at the end, pop that student's name in, give them a line of what they did brilliantly, and then send it home. I've had a couple of ones from my children where a teacher has sent something home. It is just a PowerPoint certificate that they've created, but it had such an impact on the fact that they've engaged in the class. So absolutely, if your students are modifying things, use it. You know, that whole idea of hands off. Okay, well, you fiddled with something. Let's use it. We're also benefiting other subjects as well, because what we're doing is by saying hands off, not touching it, solve it yourself, we are improving their ability to problem solve in other subjects. There is a real reason why we are a foundation subject for many of the university courses. And it's because they know that if they have studied computer science, then they will be able to solve problems independently. You know, we are now a foundation subject for medicine as well, which is just the most amazing thing ever. And the one big thing that I ban in my classroom is the words, I don't get it. Because it's not descriptive. Tell me what you've done. Tell me what the problem is. Explain to me what it is that you don't get. pinpoint something and I'll help you, but completely hands off, then we need to work through the next stage. And the next stage is, of course, SNOT. SNOT is one of my favorite things ever. When I discovered that I could go from 3 before me into SNOT, I was absolutely delighted. SNOT basically stands for self, neighbor, other, teacher. It is a way of making our students more independent. Now, I've had SNOT sheets in my physical classroom for a very long time, where they have to tell me what they did themselves, what their neighbour said, so the person sitting next to them or the person sitting opposite them, what other resource have they tried, whether that's looking online, looking up in a book, having a look at what they've done before, and then they can ask me, but not until they've done those 3 things first. This is 3 before me with a much better name. I don't actually know who came up with the SNOT acronym, but I will find you and I will thank you. So this is how I use it in my Google Classroom. In terms of Google Classroom, this allows us to have things where our students are getting stuck and then helping each other. This is essentially peer feedback, but it also shows that you are encouraging your students to work independently, and there is I would say an audit trail essentially of these students asking for help on what happened and what feedback was given, what did they do. If you need to show that you are providing feedback in your live lessons, this is amazing. So in terms of this, I created as an assignment. I add that assignment, so I give them an explanation of what SNOT actually is. And you can see here I was typing things in live, so I was making sure that I was checking my spelling. So they don't get a huge introduction to this because a lot of my students already know what SNOT is. If you haven't used the 3 before me technique, and if you haven't used SNOT before, then obviously give them a slightly longer introduction. In fact, I'm going to get you to give me a hands up in the attendees area. Could you pop your hand up if you have used either 3 before me or SNOT before? I've got a few. So for those of you who don't have your hands up, this is a game changer. This is absolutely brilliant. So here you can see I will be very open with my students to say, yes, this is definitely self. You know, tell me what you have tried first. Tell me what you have asked. Now, your neighbor is going to be very difficult in this particular scenario, and this is why we are creating the digital form. Other might actually be, I've looked online. And then, of course, teacher is where they send you that personal message. Might be an email, might be a message actually inside your digital classroom. And what I do is, in order for them to actually tell others what they have done and to connect with a neighbour, we created a Google form. So you can either go to add if you wanted to create something which is away, or you can just go directly to create, and you can go to create forms. Now for this one, I had like a million tabs open. So my poor Google Classroom actually did fail the first time. If it does, just try again. They're being overloaded. So in this case, I went back to create, went to forms, it worked the second time. Okay, now Bart, as a newbie to teaching computer science, this is going to be so powerful for you, especially when you are going to have a class full of students who are trying to do live coding lesson. They will have an absolute ton of errors, and this is going to help them to help each other and actually become more independent, because ultimately if they can fix their own code, then actually once they get to doing the code for the actual GCSE, and then of course for A-level as well, they are going to be far more capable, and they're going to be less stressed about the programming exam. So you can see here I'm only going to ask them 3 minor questions, and they are going to be paragraph questions. These are then going to be taken and put into a spreadsheet that everybody can see. Yes, drilling independence early is the absolute key. And you know, this is something that comes from computer science teachers, from tutors, from absolutely everybody. Independence as soon as you possibly can. So these are the questions that actually I ask students. If I was working one-to-one with them. So what problem did you find in your code? What have you tried so far? What did you try? Don't talk to me until you've tried something, rather than, it didn't work. So ask them about the error message, and if they are getting an error message, paste it in. Now, this is really good because if other students are helping to answer the questions, then what's happening is that they are starting to recognize the error messages in your programs, which means that when they come to it, they'll be able to then answer it themselves. So you can see here, I have 0 responses, but instead of using the responses on the form, I am then putting them into a spreadsheet. Okay. So if you want to see some examples of this, one thing that you can do on here is on the handouts. There are 3 handouts on here. And you can download all of them. One of them is the ability to write little notes next to each of the slides. Another one is going to be a poster, which we're going to look at next. So on here, once we've created our new spreadsheet, what you will be able to do is to go directly into your questions. You can see there, and you will actually see a timestamp. So the timestamp shows when they actually sent the question in. I then do a little bit of formatting, just so that I can actually see what the titles are. And then finally, we add an extra column at the end for potential suggestions as well. Now, one little caveat on this, even though I've created the form directly in my Google Classroom, it's really, really important to also link to the spreadsheets in your assignment. Otherwise, the students won't be able to get to this and it will remain personal to you only, at which point the whole peer feedback kind of falls apart. So once you get to the point where you have those 3 questions there, you have your spreadsheet as well, you can then send that assignment out to all your students with no due date at all, because technically there isn't a due date, and they can fill that form in as many times as they like, and throughout each of your lessons, have the spreadsheet open to assist other people. So if they finish the task that they're doing right now, or they have a little break, they can pop on, they can help, leave their name in there, because that does mean that you can then go back to your achievement points and you can provide feedback to not only the students that are completely stuck and really manage your time well, but you can then also give that feedback to the students who are helping, because they are helping to move forward. How do you stop somebody from vandalizing the whole spreadsheet? Right, that is the perfect question for our next slide, because it's behavior management. There are certain things that you can't stop somebody from vandalizing the whole spreadsheet. One thing you can do, certainly in Google Docs and Sheets, is that you have the history tab. And if you go to the history tab, you can see who vandalized the spreadsheet and deal with them as you would do in a physical classroom. So our behavior management is no different really in terms of digital to being in an actual classroom. It's just that you actually have all of the tools to show exactly who did what in your classroom. So there is absolutely no arguing who touched it. So what we also have is inside your handouts is my online classroom chart of expectations. I'm sure loads of us have this for standard behaviour in our classrooms, or this one is for a digital classroom. So it's just taken what we want them to do, our expectations, and this has been developed over a number of years where I have been working with students in a digital environment. So we look at this one in terms of technical issues. So I expect all of my students to have tested their internet speed before they join, testing their microphone and speakers, making sure that you have installed any software updates, because the last thing you want is a software update turning your computer off in the middle of a lesson. Making sure they've got their resources. So most of us have this in class. We make sure, pen, pencil, planner, paper, it has to be there at the beginning of every lesson, and that's no different for a digital classroom. We need them to have a pen and pencil and probably a calculator as well. as much as digital classrooms are absolutely incredible, there is no way I could manage as a student without writing my notes. And then, of course, talking to parents. So I use a 3-strike system. So Bart, I really hope that answered your question. Now, I am very, very aware of the time. So what I am going to do, I don't think we've got brilliant. Okay, so we're at the last one. I'm just going to very, very quickly go through Prim at an absolute rate of knots, and then I'm going to hand back to Beverly. So this is what we have been looking at for the entire session. We have been looking at using Prim as our essentially teaching model. Using our pre-created resources allows our students in Make Code and Trinkets to run our pre-tested code, predict what's going to happen, and then run it to test their predictions. So this is a really useful way to test your confidence online, in addition to the way that you test your students' confidence with using digital. Then we have our pre-created resources to demonstrating through our screen sharing. Make Code and Trinkets allow you to run and modify your pre-tested code so you can adjust things. So we're building up confidence at this point. Repl and Code Collab allow our students who are a little bit more advanced to work together on that skeleton code. So what they're doing is they are then modifying the code. So we're nearly at the end. And then finally, we have our modifying and actually making for our students. So this is more Key Stage 4, Key Stage 5, potentially even make code for Key Stage 3, saying right from the beginning, go and create something. Let's give you a code challenge, which you start at the beginning of the lesson. And I'm going to, as a teacher, pop into each of your personal code pages, and I'm going to give you feedback, and we're going to look at the other things that students have created. And then finally, you've got Repl and Code Collab, allowing students to work collaboratively together in small groups with their paired programming to actually make their own code and you to be able to run it. I'm going to take a massive deep breath because we have 3 minutes left to pass over to Beverly. I hope that did answer as many questions as you had during the session, but if you do have any more questions, then you are very, very welcome to contact me as well. Okay, over to you, Beverly.
Hi, thank you everyone for joining today. Just a few big takeaways for me from that session: turning the physical classroom into a digital classroom, the collaborative coding, the Repl for Key Stage 3 to 5. Please, just put what your big outcomes were from this session onto the CAS website, onto the CAS Facebook pages, share it via Twitter. I also enjoyed Digital Snot. I was aware of it, but not by that name, so that was quite interesting. And the behavior management infographic, which I will certainly be tweeting shortly. Just to let you know what's coming up. So next week, Holly joins us again, looking at group microbit training, so very much looking forward to that. We also have launched the CAS Virtual Showcase, so that is our summer conferences, which would have been face-to-face, and now all available as a virtual showcase, and booking is live. So to book that, go to the CAS website, go to the news section, read the news section, and there is a link at the bottom there which shows all of the workshops available. There's still a few more to come, and also the booking link is there. So please do sign up for the CAS Virtual Showcase. Thank you very much for joining today, and I look forward to seeing you again soon. Thank you.
Thank you.